Hi everyone, welcome to another video, and today I'm going to be going through the topic of rivers. So the first thing you need to know about rivers is the hydrological cycle, and it can also be referred to as the water cycle. So this term may be interchangeably used in the exam, so make sure you know what they mean. So I'm going to be going through a few of the processes that happen in this cycle, so I'll be giving the definitions of each of them. So the first one is evaporation, and the definition for this is the transfer of water in a liquid state to a gas. And you can also use water vapor here as well. Okay, the second stage is condensation, and this means when water cools from a gas, or you can also use vapor again, gas or vapor state, into a liquid in order to form clouds. Okay, so the next definition you need to know is evapotranspiration. So evapotranspiration is the combined transfer of water from the surface and plants to the atmosphere. So all you need to know is that evaporation happens from the sea and transpiration happens from plants. So precipitation is the transfer of water from clouds to the surface. But precipitation may not necessarily be in rain all the time. It can be in the form of hail, sleet, or snow as well, but it can also be rain. So just make sure that whenever they refer to precipitation in the exam, it may not exactly be rain. So the next thing you need to know is overland flow. And this is the process where water from precipitation flows along the surface to a body of water, such as like a sea, a lake, etc. Alright, so the next thing you need to know is percolation. Actually, I'll go through infiltration first and to keep it in an order. So infiltration is when water moves from the surface to the soil layer. And then percolation is when water moves from the soil layer into the rock layer. Okay, and then I'll go through, this is stir flow, so that means the movement of water through the soil, and groundwater flow is the movement of water through the rock layer. And keep in mind that the rocks in this layer are quite permeable, so it allows for water to move through. And the final thing you need to know is interception, and this is where water is captured and stored by vegetation. Okay, so these are mainly all the definitions that you need to know, and I would recommend just memorizing them because they often come up in the exam. They will probably ask you for a definition or for you to refer to them, like in a 3 or 5 mark answer. So the next thing we're going to go through is a drainage basin, and a drainage basin can be defined as the area in which a river drains and its distributaries. So again, I would recommend learning this definition here off by heart because it comes up a lot in past papers, so I would recommend going through it. So you need to know the features of the drainage basin. So one of them is the watershed, and this is the boundary between two different drainage basins. Keep in mind that the red dotted line is imaginary, so it just represents where the watershed is. So the second thing you need to know is the source, and this is the point at which the river starts. And this is usually located in the upper course in the river, but I'll go through the different courses of the river later in this video. The second thing you need to know are tributaries, and these are smaller streams that join the main stream at a confluence. And this leads us to the definition of confluence, which is the point at which two streams meet, where the smaller stream joins the main stream. And the final thing you need to know is the mouth, and this is the point where a river joins a larger body of water, such as like a lake or a sea. Body of water. Okay, so again, I would recommend knowing these definitions off by heart because they come up a lot as well. Okay, so now we're going to be looking at the erosional processes in rivers. It's quite similar to coasts, which I'll cover in a future video. But for now, I'm going to be going through the ones that are relevant to rivers. So the first one is attrition, and this is when material carried by the river carried by the river knocks into, so they knock into one another, which decreases sediment size. And the next thing you need to know is abrasion. And this is when the riverbed and bank is scraped away by the load. And if you need to know what the riverbed and bank is, this part here, this is the riverbed. And the sides here are the riverbanks. Okay, so next thing you need to know is solution. So this is when sediment is dissolved due to the high pH, or you could say high acidity of the water. And the final thing you need to know is hydraulic action. So this is the force of water and air getting into the cracks of the bed and banks. Okay, so that's for river erosion, and now you need to know the river transportation processes as well. So the first one is suspension, and this is when light material is suspended within the water. So light material is held in the water and transported. The second definition you need to know is traction, and this is when large boulders roll along the riverbed. Okay, so then you need to know solution as well. This is very similar to the one above. So when sediment is dissolved in water with a high pH or acidity. And then finally, you need to know saltation. And this is when smaller materials, such as like small rocks or like clay, so they will also, it's similar to traction, they will also bounce along the riverbed. So small salmon bounce along the river bed. Okay, so one important model that you need to know for rivers is the Bradshaw model. And this basically shows how characteristics change as you go downstream a river. So I'll be going through the definition for each one and how it changes as it goes downstream. So if you see the point, the vertex at the upstream here, and then if you see that it gets wider as you go across, that means that it increases downstream. So for discharge, discharge increases downstream. And you also need to know not definitions, like you need to know the explanations for why it happens. So for discharge, it's because there is more water being added from tributaries. More water from tributaries, okay. And if you're not sure what discharge is, it's basically the amount of water passing a point in a given period of time. Okay. So next thing you need to know is the occupied channel width, and this also increases downstream. And this is because there is more lateral erosion. So that means that there is more erosional processes on the banks of the river, so which increases the width of the channel. And if you don't know what channel width is, it's how wide a river is. And the important part here is occupied. So occupied means made up by water. Okay. So the next thing you need to know is channel depth, and this increases downstream. And this is because there is more vertical erosion. And then the definition for this is how deep a river is. And the next thing you need to know is average velocity. So this is the speed at which the water travels. And this increases downstream. Because there is more water being added, which pushes the water to be faster from tributaries. So more water added from tributaries. Okay, and the next thing you need to know is the low quantity size. So this increases downstream. And this is because load is added from tributaries. And low quantity is how much material the river carries. All right, so now we're going to look at the characteristics which are large in the upper course but decrease over time as they go downstream. So one thing is the load particle size. So this decreases. And this is because of attrition, where rocks bounce off each other, so it makes them smaller. And the definition for this is the dimensions of sediment in a river. And the next thing you need to know is channel bed roughness. So this decreases downstream. And this is because there is more net lateral erosion downstream than vertical erosion. So this causes the channel bed to smoothen out. So more net lateral erosion. And the definition for this is a measure of how rough or smooth the riverbed is. And the last thing you need to know is the gradient. So the gradient decreases downstream. And this is because the source of the river is in a mountainous area wherever the mouth is in the flatter area. So the stream moves from a mountainous to more flat land. Okay. Okay, so that is all you need to know for the Bradshaw model. It looks like quite a lot, but you can just tell the trend first of all by looking at the model, and you just need to be able to explain why that happens. So what you need to know is the upper course, the middle course, and the lower course and those characteristics. And you can kind of derive that from the Bradshaw model. So for example, in the upper course, you can see the characteristics is a low discharge because of the smaller kind of triangle here. And that means lower occupied channel width, lower channel depth, lower average velocity, lower load quantity. However, there's a large particle size, a large channel bed roughness, and the slope, a large gradient. And you can do the same for each of the other courses. So for the middle course, it would be you would just say it's has a larger discharge than the upper course. So I would recommend like comparing them relative to each other in the exam, because that's what they're looking for. So the next thing you need to know are the river landforms. And first we're going to be focusing on the upper course landforms, and the only one you need to know is a waterfall and how it forms. So basically, over here, there's a plunge pool, as you can see by the diagram. And this causes hydraulic action and abrasion against this rock here, which is the soft rock, and so has less resistance to erosion. And also the water here might undercut under the hard rock. So this can cause erosion here on this part of the soft rock. And eventually, as you can see, cracks start to form on the hard rock here because it cannot be sustained because there's no rock underneath it. So eventually this will collapse here. And then this process just continues repeating as you go upstream. So the waterfall will keep retreating. And you also need to know that it will leave a valley side called a gorge. And these terms should not be used interchangeably. So if you're talking about gorges, it only relates to waterfalls. So you should not be using it interchangeably with valley sides. So the second thing you need to know is meanders. And this forms because in lowland areas, lateral erosion is dominant. So on this side of the river channel, on the outer bend, there is increased velocity. And in the inner bend, the water flows slower. So because the water is flowing slower, it has less energy, so then it deposits its load, which can be found here. And the area in which the river deposits its load is called a slip-off slope. Okay, and this process will continue, and then eventually it forms like a neck of a meander. So this is when the two corresponding streams get closer and closer together. And eventually the water will break through here when they both connect. And this results in deposition on which is now the outer band because there is less velocity. And this causes the separation of this kind of oval shape here from the main channel, which is here. And this oval shaped lake is called an oxbow lake. So this is cut off from the river, and eventually it will dry up because there's no source of water that fills the lake. So that's all you need to know for meanders and oxbow lakes. So the next thing you need to know are potholes. So basically what happens is that there is it usually occurs when there's large vertical erosion. So because of turbulent water flow, it causes these rocks to like push themselves into the riverbed because of vertical erosion, and this can create little like eddies. So this thing here is called a pothole actually. But then the turbulent flow of water here, so these arrows, they can be called eddies. So all you need to know is that eddies causes rocks to erode into the bed of the river due to more vertical erosion, and that forms a pothole. So the next thing you need to know are how floodplains and levees forms. So floodplains form because of when floods happen. So when floods happen, the water level rises, and this causes water to like flow into these kind of ditches, and this is what is called a floodplain. So in floodplains, you'll find smaller sediment. So this can be like sand, soil, and also alluvium, which gives the land its fertility. And another thing you need to know is how levees form. So when the water flows into the floodplain, it has less energy. So then it will deposit the hard rocks and boulders on the banks of the river. And this is what levees are. So levees are basically raised banks formed from large boulders. Okay. And the next thing you need to know is how deltas form, and these usually occur in the lower course. So as the water approaches the mouth of the river, it starts to lose its velocity. So as a result, it starts to deposit sediment at the mouth of the river, which can be seen here. However, the water still needs to flow, so it creates these little channels here, as you can see. And these little channels here are called distributaries. And this allows the water to still flow into the sea or the lake or the body of water that it's going into. So that is how deltas form. So the next thing you need to know are the causes of flooding and river erosion. So there's a variety of causes for this, and one of them is deforestation. And this occurs because there are less trees to intercept the water from precipitation. So this results in increased overland flow. So it goes into the river, and then it can cause the river's level to rise. So there's less trees to intercept water from precipitation. Okay. And then the next thing you need to know is that urbanization is also a cause. And this is because the infrastructure in urbanization leads to impermeable surfaces, such as roads and concrete, etc. And this means that the water can't infiltrate into the soil because of these impermeable surfaces being constructed. So this can lead to increased surface runoff, which increases flooding. So next thing you need to know is agriculture. And you need to know that the crop density is low. So that means there'll be less interception compared to when there is vegetation there, such as trees and bushes. So this leads to increased surface runoff. So another thing that can cause flooding is dams being built. And this is because the dams hold the river upstream. So the water keeps building and building up behind the dam. So this could cause the river to burst its banks and flood. So holds water upstream. And also another reason why flooding happens is because of intense rainfall. And when this happens, it saturates the soil until its maximum capacity. And then when it reaches this capacity, it cannot take any more water. So this leads to increased surface runoff, which therefore increases flooding. So although flooding is dangerous, there are many opportunities that rivers can provide. So the first one is fertile soil. And this is because the land is well drained around the river. So it allows for agriculture and crop growing. So the next it can provide is transport. And this can boost the local economy of the settlement which is located near the river, because it allows for the trading and transport of goods and services. And the next thing you need to know is it provides food. And this is because rivers allow for fishing to happen. So it increases food production for the settlement. So there is a less chance that the people of the settlement will contract diseases such as malnutrition or salmonella, etc. And it can also boost tourism. And this is because some visitors may like to be near rivers. So this can also boost the local economy. And finally, it can also be used for irrigation of crops. And this is because water can be taken from the river and can be used to water the crops that farmers are growing, so then they can harvest them. Okay, so the next thing we need to know are the mitigation strategies to prevent flooding. So there's two types of engineering that takes place to mitigate floods. So the first type is hard engineering, and this is the building of artificial structures to decrease the effect of flooding. So some examples of hard engineering can include the building of dams, and this is because it regulates water flow downstream. So this means that floods in the lower course are less likely to happen. But however, earlier in this video, we discussed that dams hold water behind it. So this can increase flooding upstream. So there are some disadvantages to these strategies. So the next thing you can, the next hard engineering method are levees. And this is because the water needs to flow to a high level in order to flood nearby areas. To flood to high levels to overcome the levees. And finally, you can also talk about flood relief channels. So these are channels that divert water away from urbanized areas, which then can lead to a decrease in flooding in those areas. Okay, so now we're going to be looking at soft engineering, and this uses the environment to decrease the effect of flooding. So for this, the first thing you can do is afforestation. And this can cause more interceptions, so then there's less surface runoff, and therefore there's less flooding. The second thing you can do is floodplain zoning. And what this is to move settlements away from areas that are likely to flood. So this decreases the effect on humans. And finally, what you can do is wetland conservation. And this is quite similar to floodplain zoning actually. So these areas provide an alternate destination for excess water to flood. Okay, so now I'll briefly go through the case study and what you need to know for your case study for rivers. So your case study for this topic is a river so this can be the rivers Jordan, Valency in the UK, the river Ganges in India, or any other river. But I would just double check with your teacher to make sure that it's an appropriate river to use for your case study. So what you need to know for your case study are 3 causes of flooding. And you also need to know the effects and the hazards that is posed to the people living near the river because of flooding. And you also need to know 3 solutions, so like 3 mitigation strategies. So you would need to know in total probably 9 pieces of place-specific information for this case study. So anyways, that is all for rivers. I hope you enjoyed this video, and bye.